In this video, we're going to find the volume of a solid or revolution using the shell method. Now, officially, it's called the cylindrical method in textbooks. It is an alternative to using the washer method. So let's take a look at a solid or revolution. Rotate the region bounded by y equals 2x squared minus x cubed and y equals 0 around the y-axis. The first thing we have to do is graph the bounded region, and then locate the shaded region. Draw the rotation and a cross-section. Now if we were to do the washer method, a cross-section would be a washer and it would look like this. There's two reasons why we can't use the washer method with this problem. First, the inside and outside radius use the same function, and that would not work with our formula. Second, notice that the washers are slicing about the y-axis. This means that all the functions need to be in terms of y. We can't do that with this function. Therefore, we need a new technique. Again, that's what the shell method's for. In the shell method, instead of cross-sections being a washer, they will now be cylinders. First, locate the axis of revolution. In this case, it's the y-axis, or x equals 0. Instead of slicing through the shaded region perpendicular to the axis of revolution to get a washer, we're going to slice through the shaded region parallel to the axis of revolution. This gives us this line that we will now rotate around the y-axis. You can actually see after the rotation, it gives us a cylinder. Notice that if we create another shell, the sides of the cylinder move left and right along the x-axis. That means the integral will be in terms of x. So a nice trick to remember is that the variables from the shell and washer will have to be the opposite. In this example, the washer was in terms of y, and so the shell is going to be in terms of x. The volume of the solid will be the sum of the surface area of these cylinders. Now the formula for the surface area of a cylinder is 2 pi times the radius times the height. Now this gives us the volume of the solid as the integral from a to b of 2 pi times the radius times the height. Now our job is to determine the expression for the radius and the height. Recall that when you were trying to represent a distance on a graph, a horizontal line is either x or what x equals in terms of y. And a vertical line is y, or what y equals in terms of x. In this case, the shell radius is x, and the height of the shell is y. But since we're in terms of x, we need to know what y equals. And that's y equals 2x squared minus x cubed. So the height will be 2x squared minus x cubed. Putting this all together, we get the integral from 0 to 2 of 2 pi times x times 2x squared minus x cubed. We can factor out the 2 pi and then simplify the integrand to get us 2x cubed minus x to the fourth by distributing that x in. Evaluate the antiderivative. We'll get 2 pi times 2x to the fourth over 4 minus x to the fifth over 5, evaluated from x equals 0 to x equals 2. Plug in the top and the bottom bounds and subtract to get a final volume of 16 pi over 5.